N.Kiran. I am working as an assistant professor in the department of EEE Anits. I welcome you all to my fifth lecture under the first module of DC generator. In my first lecture, I discussed the construction details of DC generator. In the second lecture, we have seen the working of DC generator and how commutator plays an important role in the working of DC generator. In the third lecture, we have derived the EMF equation of a DC generator, and in my fourth lecture, I have discussed the various types of DC generator. In today's lecture, we are going to solve some of the tutorials based on the concepts that we have learned in these four lectures. So, the first tutorial, 4-pole lap wound DC generator running at 900 rpm has armature resistance of 0.2 ohms and shunt field resistance of 200 ohms. There are 30 slots on armature and 15 conductors per slot. If the load resistance is 10 ohms and terminal voltage is 230 volts, find the useful flux per pole. Assume contact per brush to be 1 volt. So first we'll see the given data. Given that number of poles is equal to 4, so capital P is equal to 4. Next, since it is lap wound, so A is equal to P is equal to 4. Speed is given as 900 rpm. Armature resistance is given as 0.2 ohms and shunt field resistance RSH is given as 200 ohms. Load resistance is given as 10 ohms. Terminal voltage is given as 230 volts. Since we have, so it's clearly mentioned that there are 30 slots on armature and 15 conductors per slot. So that will give me my total conductors to be 30 into 15, that is 450. Next, here we know the value of terminal voltage, we know the value of load resistance. So from that we can get load current IL, which is nothing but V by RL, which will give me 23 amps. We also know terminal voltage, we also know shunt field resistance. So that will give me shunt field current ISH to be V by RSH, which is around 1.15 amps. Next, since we know load current and also shunt field current, we can get the value of armature current IA. So since this is since nothing is mentioned here, the type of generator, so by default we assume that it is a shunt generator. So in shunt generator, IA is equal to IL plus ISH. So if I calculate that value, that gives me the armature current to be around 24.15 amps. So we also know the expression for generated EMF EG, which is V plus IARA plus total brush drop. We know the value of V. We know the value of terminal voltage is already given. IARA value we know. Here it is asked. Here has asked us to assume 1 volt per brush. So your total brush drop will be 2, since I have 2 brushes for every machine. So if I calculate that, that will give me the value of generated EMF to be around 236.83. But we also know that generated EMF is 5Zn by 60 into P by A. Here all the values are known. The only unknown value is flux. So from that we can get the value of flux to be 0.035 Webers, which is the required solution for this tutorial. The next tutorial, 4-pole wave wound DC generator, consists of 51 slots and each slot consists of 20 conductors. Find the generated EMF in the machine which is driven at 1500 rpm. Assume flux per pole is 0.7 milliweber. So given data, same 4-pole machine, P is 4. So here we have 51 slots and in each slot we have 20 conductors. So the total number of conductors will be 51 into 20, 1, 2, 1020. Since it is wave wound, A value is 2, speed is given as 1500 rpm, flux is also given as 0.7 milliweber. We are asked to find generated EMF. We know the expression for generated EMF. It is phi Zn by 60 into P by A. Here we know all the values. You just upon substitution, it will give me the value of generated EMF to be around 35.7 volts. The third tutorial, an 8-pole DC generator has 500 armature conductors and useful flux of 0.05 Weber per pole. What will be the EMF generated if it is lap wound and runs at 1200 rpm? What must be its speed at which it must be driven so as to produce same EMF if it is wave wound? So here we have two cases. First we need to consider lap wound. The second case we need to consider wave wound. So given data, since it is 8 pole, P is equal to 8. So number of conductors is 500 and flux is given as 0.05. First it is lap wound. So the number of parallel paths A1 is equal to P, which is nothing but 8. And speed is also given, let us assume as at N1, and which is equal to 1200 rpm. And we are asked to find the generated EMF. We know the formula phi Zn by 60 into P by A. So I just substituting all the values in the formula. That will give me EG value to be 500 volts. Next, in second case, we are considering wave wound. So for wave wound, it is A is nothing but 2, and also given that the generated EMF is same. So according to this formula, if EG is same, so EG is constant, phi Z P 60, all are constants. So using that relation, I can get N1 by A1 is equal to N2 by A2. So I know N1 A1 values, I also know A2 value. From that I'll calculate what is my speed in case of wave wound, which is around 300 rpm. Fourth tutorial, a 4-pole lap wound DC shunt generator has field resistance of 50 ohms and armature resistance of 0.1 ohms, which is supplying 60 100 volt 40 watt lamps. Find the armature current in each conductor and generated EMF. Assume 1 volt per brush. So given data, P is given as 4. Since it is lap wound, A is equal to P is equal to 4. Armature resistance is given as 0.1 ohms. Shunt field resistance is given as 50 ohms. And terminal voltage is 100 volt. So here clearly it is given that each lamp rating is 40 watts and we have 60 such lamps. So the total power rating will be 60 into 40, which is 2400 watts. Okay, so we know the power, we know the voltage. So load current will be power by voltage, which will be around 24 amps. Next, we also know RSH and V. So we can also find shunt field current ISH, which is V by RSH, which will be around 2 amps. So we know load current, we know shunt field current, so that will give me the armature current IA is nothing but IL plus ISH. If I calculate, that will give me around 26 amps. So now here that is what we are asked to find, isn't it? What is the armature current in each conductor? So and also generated EMF we need to find. You know the formula EG is equal to V plus IA RA plus total brush drop. So V we know, IA value we know, RA know, we also know 1 volt per brush. So the total brush drop will be 2. So upon calculating, it will give me the value of generated EMF to be 104.6 volts. So the fifth tutorial, long shunt compound generator delivers a load of 50 amps at 500 volts. It has armature series and shunt resistances of 0.05 ohms, 0.03 ohms and 250 ohms respectively. Assume 1 volt per brush, calculate armature current and generated EMF. So given data, load current is given as 50 amps, terminal voltage 500 volts, armature resistance 0.05 ohms, shunt field resistance 250 ohms, and series field resistance as 0.03 ohms. Okay, so since this is long shunt compound, ISH is equal to V by RSH. So we know RSH value, it is 250 and V is 500, that will give me 2 amps. So we also know that IA is equal to ISC in long shunt compound generator, which is again equal to IL plus ISH. So we already know IL, we already calculated ISH, that will give me armature current value to be around 52 amps. We are also need to find generated EMF, which is V plus IARA plus total brush drop. Here total brush drop is 2 volts, and just substituting all the values, that will give me my generated EMF to be around 506.16 volts. A short shunt compound generator delivers a load of 30 amps at 220 volts. It has armature series and shunt resistances of 0.05 ohms, 0.03 ohms and 200 ohms respectively. Assume 1 volt per brush. Need to calculate armature current and generated EMF. So given data, load current is 30 amps, terminal voltage 220 volts, RA, RSC, RSH are 0.05, 0.03 and 200 ohms respectively. So here we need to find IA value. So first we need to find ISH, since it is short shunt. So it is V plus ISC RSC by RSH. Okay, V value we already know. ISC value, since it is short shunt, so ISC is equal to IL. So ISC will also be equal to 30 amps. RSC value we know, RSH value we know. So just if you substitute, that will give me my shunt field current ISH to be 1.1 amps. So next, calculating armature current, it is nothing but IL plus ISH. So upon adding these two values, will give me around 31.1 amps. We are also need to find generated EMF. So total brush drop is 2. So just substituting all the values, that will give me EG value to be around 224.45 volts. Next, seventh tutorial. A series generator delivers a current of 100 amps at 250 volts. Resistance of armature is given as 0.1 ohms and series field is given as 0.55 ohms. We need to find generated EMF. So we know the given data, since it is series generator, IL is equal to IA is equal to ISC, which is given as 100 amps, and RSC is given as 0.55 ohms. Terminal voltage is 250. RA is given as 0.1 ohms. We know the formula, since it is series generator, VPG is V plus IA into RA plus RSC plus total brush drop. We know all the values. So since nothing is mentioned about brush drop, so total brush drop is 0. Substituting all the remaining values, that will give me my value of generated EMF to be around 315 volts. Eighth tutorial. A 120 volt compound generator has armature shunt series resistances of 0.0 ohms, 6 ohms, 25 ohms and 0.04 ohms respectively. Load current is 100 amps. Find induced EMF and armature current if it is connected as long shunt and short shunt. Okay, so first, given data, load current is given as 100. Terminal voltage is given as 120, and RA, RSC RSH are also given respective values. First, let us consider long shunt compound generator. So in that, we know the value of ISH, formula is V by RSH. So upon substitution, that will give me ISH value around 4.8 amps. Next, so we already know IL, isn't it? So armature current IA will be nothing but IL plus ISH. So upon adding those two values, that will give me around 104.8 amps. So next, generated EMF, we know the formula V plus IA into RA plus RSC plus total brush drop. Here nothing is mentioned about brush drop, so its value is 0. So upon substitution of all the values, it will give rise to EG around 130.48 volts. So in the second case, I need to consider short shunt generator. So the same values of RA, RSH, RSC are same. IL is given as 100 amps, V is given as 120. So we need to find IA, isn't it? So in order to find IA, first I need to find ISH. Since it is short shunt compound, ISH is V plus ISC RSC by RSH. If I calculate, it will be around 4.96 amps, which will give rise my armature current to be as 104.96. So we need to add that load current and shunt field resistance, shunt field current values. EG will in this case will be V plus IARA plus ISC RSC plus total brush drop. Again here the total brush drop is 0 since it is not mentioned anywhere in the sum. So upon just substitution of all the values will give me EG value to be around 130.29 volts. My ninth tutorial, a separately excited DC generator has armature circuit resistance of 0.1 ohms, total brush drop 2 volts while running at 1000 rpm, delivering a current of 100 amps at 250 volts to a load of constant resistance. If generator speed drops to 700 rpm with field current unaltered, find current delivered to the load. So since it is separately excited DC generator, here RA is given as 0.1 ohms. Initially speed is given as 1000 rpm. So let us assume N1 to be 1000 rpm. Initially load current is also given as 100 amps. So I'll assume IL1 to be 100 amps. Terminal voltage also is given as 250, so I'll assume V1 to be 250. Next, since the second case speed also is given, so N2 value is 700 rpm. So here he has given that field current is unaltered, so it means that flux is constant. So next, we know the formula for EG, isn't it? Phi Zn by 60 into P by A. So in that flux, if flux here is also constant, so putting aside all the constant, so I can write the expression Eg1 by Eg2 to be equal to N1 by N2. Okay, so next we know, so first we need to find what is EG, isn't it? So Eg1 is V1 plus IL1 RA plus total brush drop. Nothing is mentioned again here. Total brush drop is given as 2 volts, so that's fine. So all the values we know, just upon substitution, that will give me my EG value to be 262 volts. Next, in the second case, so here EG2 we need to find. EG1 we have found, N1, N2 we know. So from this relation, if I substitute the values, that will give me my EG2 value to be 183.4 volts. So here one need to remember that given that RPM has dropped to 700 RPM and field current is unaltered and the load is of constant resistance. So keep in mind these three data that are given in the tutorial. So since we have found out Eg2 value, we know the formula. Eg2 is V2 plus IL2 RA plus total brush drop. Total brush drop I know, RA value I know, IL2 I do not know, V2 value also I do not know. So here, since I am having two unknowns here, so remember that it is given in the tutorial that the load is of constant resistance. So it means RL is constant. We know that IL is equal to V by RL. Okay, so we know the value of IL1, we know the value of V1. From that I will calculate the value of RL, which is around 2.5 ohms. Now IL2 is equal to V2 by RL. So since load is constant, the same RL will continue in this case also. So here also that will give me around V2 to be around 2.5 IL2. I'll assume that as equation 1. Next, Eg2, we have seen this expression. So I'll substitute that in this expression. So we know the Eg2 value, it is 183.4. V2 is nothing but we have got expression as 2.5 IL2, and RA value also I know it is 0.1. So total brush drop is not given, I think. No, it is given, it is 2 volts. So from this, if I solve, that will give me my load current in second case to be 69.76 amps. Okay, so that is what we need to find, isn't it? Find the current delivered to the load. So IL2 we got as 69.76 amps. 10th tutorial, separately is of similar type to the previous sum. A separately excited DC generator has armature resistance. So armature resistance is given as 0.04 ohms. Total brush drop is given as 2 volts while running at 1200 rpm. So in first case N1 is given as 1200 rpm, delivering a current of 200 amps. So IL1 is 200 amps. Voltage is given as 125 volts. So V1 is 125 volts. Here the load is of again constant resistance. If the speed reduces to drops to 1000 rpm, so N2 is given as 1000 rpm. In field current reduced to 80%. Previously in previous sum field current was unaltered, so that is why flux was taken as constant. But here in this case field current is reduced to 80%, so flux is no longer constant in this sum. Find the current delivered to the load. So since flux is not constant, so my expression will change here. That I will come to that later. First I'll find the value of Eg1. V1 value we know, IL1 value we know, RA value we know. Total brush drop, is given as 2 volts. So just upon substitution will give me the value as around 135 volts. Next, given that the field current is reduced to 80%, so my expression will be Eg1 by Eg2 is equal to N1 by N2 into Phi1 by Phi2, because since flux is no longer constant here, so we need to consider flux also. So here it is given that field current is reduced to 80%, so that ratio is nothing but 0.8. so next, N1 value we know, N2 value we know, Eg1 we know. So from this we will get the value of Eg2, which is around 90 volts. Again Eg2 we know that it is V2 plus IL2 RA plus total brush drop. So here V2 is unknown, IL2 is also unknown. So but it is given that RL is constant. So from that we will first find the load resistance. IL1 is V1 by RL. That will give me RL to be 0.62 ohms. So IL2 is also V2 by RL. So that will give me the expression V2 is equal to 0.62 into IL2. So substituting that in my generated EMF expression, so that will give me 90 is equal to 0.62 IL2 plus 0.04 IL2 plus 2. And that will give me the current delivered to the load IL2 to be around 133.3 amps. The 11th tutorial. Now 4-pole lap wound long shunt compound generator has useful flux of 0.07 Weber. The armature winding has 220 turns and resistance per turn is 0.004 ohms. Calculate terminal voltage if shunt series field resistances are 100 and 0.02 ohms respectively, while running at 900 rpm with armature current 50 amps, and also calculate output power. Okay, so given data, it is given that it is lap wound, so it is P is equal to 4 and flux is given as 0.07 Weber. Okay, so one should clearly understand here, armature winding consists of 220 turns, it is given in the sum, and resistance per turn is given as 0.004 ohms. So directly armature resistance value is not given, so we need to find the value of Ra. So Ra is nothing but each parallel path resistance divided by number of parallel paths. So how many parallel paths we have? 4 parallel paths. Since it is lap wound, A is equal to P is equal to 4. Since I have 4 parallel paths here, so 4 parallel path resistance will be nothing but 220 into 0.004, that will give me 0.88 ohms. So this resistance is the 4 parallel path resistance. Okay, so each parallel path will be nothing but 0.88 divided by 4, since I have 4 parallel paths, which will be around 0.22 ohms. So I know each path resistance, I know the total number of parallel paths. That will give me my armature resistance Ra to be 0.22 divided by 4, which will be 0.055 ohms. So this is the armature resistance. So this is the procedure to find armature resistance if the turns and resistance per turn are given. So coming back to our sum, so here given that flux is 0.07 Webers, speed is given as 900 rpm. Here conductors are not given, but number of turns are given 220. So each turn will have 2 conductors. So total number of conductors will be 220 into 2, that is 440. So you know the expression for Eg, which is 5Zn by 60 into P by A. So just substituting all the values, since it is lap wound, A value is equal to P, which is equal to 4. So that will give me around 462 volts. We also know Eg is V plus Ia into Ra plus Rsc plus total brush drop. Okay, so here we need to find my terminal voltage V, okay, which is unknown. Eg we know, Ia is already given, it is armature current as 50 amps. So ISH I can find, that is V by RSH will be around 4.58 amps. So Ia we know, ISH we know, so that will give me my load current. So we know the formula, Ia is equal to IL plus ISH. From that I can calculate my load current IL to be around 45.4 amps. So now since I know my load current and armature current is also given, so I need to find my terminal voltage. So using that formula, this we need to substitute all the values in that Eg expression, and that will give me my terminal voltage to be 458.5 volts. Next, we also need to find output power. So formula is V into IL value we know, V also we know. Just producting those two values will give me my output power to be around 20.8 kilowatts. So this ends my today's lecture on the tutorials of the types of DC generator. So until we meet with another topic in the next class, take care, thank you, goodbye.